that in part B we have proved the identity because they said we should make it like this, and we have done that. So this is what you got to do. This was just fun for both of them. We were starting with this kind of way of splitting, eh? Like here we split a sine 3x into sine 2x plus x, huh? This game you should be good at it. Now let's do that last one, which is part C, which is saying that please do tan squared x over 2 plus pi over 4 and change it to 1 plus sine x over 1 minus sine x. So what you do is don't be too obsessed by the final stage. No, don't be too obsessed by. Just let it guide you. But you should look at what you have and see what you know about what you have and try to change using what you know. So for example, I'm going to look at this tan squared thing and say, do I know anything that I did that had a tan squared something where I was changing? No, I don't. So what should I do? I should explain what tan squared means to me. Okay, what does tan squared mean? It means you have tan of x over 2 plus pi over 4, and the squared is actually outside. Okay, you know why this is important for us? Because once we have the squared outside, it kind of helps us to see the whole picture. Let's push. So here I have the squared outside. Now I can see I can expand this because I can expand for tan. And how do you do it? Remember, you expand like in algebra, which is tan x over 2 plus tan pi over 4. Okay? And you now say O over 1. Since this was a plus, it will now be 1 minus. Then now you say tan x over 2 tan pi over 4. Now where are we trying to go? We're trying to go to this 1 plus sine x over 1 minus sine x. No problem. I'm just going to be looking at what I have and seeing what I can change. I get to this tan x over 2. I can still keep it as a tan x over 2. But this tan pi over 4, what is it? Now, I would need to be able to do those things for my exact values. I know that tan is either going to be, remember that we have a root 3 and we have a 1 over root 3. It can be positive or negative. And we have a 1 and we have a 0. So you should try to have an asymptote as infinity. So you should try tan pi over 4. Make sure your calculator is in radians. Put your calculator in rad. Okay, you press the button at a DRG until your calculator puts rad at the top. You should never punch something with a pi when your calculator is in degrees. Make sure it's in rad if you see this pi. So you put your calculator in rad and punch tan, then open bracket pi over 4 close bracket is equal to. Here I got 1, so it's equal to 1. Now remember, all this is being squared, okay? Because this which we have put is for this thing. Then there's a squared outside, so remember that there is a squared. Now, what are we going to do now? This is going to be plus 1 because this is a 1. And then we say O over 1 minus tan x over 2 times 1, okay? Because it is multiplying tan pi over 4. Then we say O squared. So here we can just say this is going to be tan x over 2 plus 1 O over 1 minus 1 times tan over x over 2 is just tan x over 2. And remember, this is O squared. Now, what do we know about tan? What else do we know about tan? Because we are trying to take it to sine. One thing which we know about tan is that tan is, I don't know if you know this, I'm sure you do, tan x is sine x over cos x, okay? This is some stuff which you did in limits when you're doing the limits. So you have to remember that tan is sine over cos. So I can then say this is just going to be sine x over 2 over cos x over 2 plus 1, okay, instead of putting 10. Divided by 1 minus sine x over 2 over cos x over 2. And this is going to be O squared. Can you see that? Now, what am I going to do? Well, I'm going to simplify this. Simplify? Yes, how? I know what 1 is. I'm going to have to put them on, they have to have the same denominator so that they make sense. I know what 1 is. 1 is cos x over 2 over cos x over 2. You know that, right? So I can just say this is going to be sine x over 2 over cos x over 2 plus, instead of 1, I'll say cos x over 2 divided by cos x over 2. All over 1 is cos x over 2 divided by cos x over 2 minus sine x over 2 divided by cos x over 2. Okay, this part, you see, and this whole thing is squared. Don't forget the squared. Don't forget the squared. We are just making them the same. This one, we are changing it so that we can combine the fractions. We want to have one thing. So since they're now having the same denominator, we can just put it once to say cos x over 2. And this will now be sine x over 2 plus cos x over 2 over cos x over 2. Divided by, in the denominator now, we have cos x over 2 minus sine x over 2, all divided by, they should have the same denominator because both of them are cos x over 2. So it's all over cos x over 2. And we square that. Now, what do? We have to keep going. We have to keep going. This is going to be equal to, now, you know what I can do? We keep this squared outside this squared, all right? And you know what we do? We just have two fractions dividing. So how do you do it? You make them multiply, but you flip this one on the denominator. So it's just going to be sine x over 2 plus cos x over 2 divided by cos x over 2 times, now we multiply the denominator, which is, it's now cos x over 2. This is now at the top, okay? Because it was in the denominator, we are multiplying, so we flip, and it's now divided by cos x over 2 minus sine x over 2. And we square. Do not forget to square. Now, what do we do when it's like this? Well, we let the cos x over 2 and cos x over 2 cancel out like this. They become 1, 1. So now we'll have this times 1, because when you multiply two fractions, the top multiplies, the bottom multiplies. So it's now sine x over 2 plus cos of x over 2 times 1, which is just going to be sine x over 2 plus cos x over 2 divided by, here it's now 1 times this, cos x over 2 minus, so this just becomes cos x over 2 minus sine x over 2. Then remember that this is all squared. Wow, how good is this? Amazing, right? It is. Now, what do we do when we have gotten to this stage? Well, once we get to this stage, we know what squared means. When you're squaring something, it means you square the top and you square the bottom. That's what I'm doing now, because what else can I do? Remember, you just look for something to change. Look for something to change as you go from stage to stage. So now I'm going to put the square at the top. It becomes now sine x over 2 plus cos x over 2 all squared, okay? You're allowed to distribute a power when things are dividing or multiplying. So this division sign will distribute. We'll put squared at the top and squared at the bottom. You are allowed. So because they are dividing, cos x over 2 minus sine x over 2. This is all squared again. So what will we end up getting? We'll now have, remember how we square things. How do you square when you have a bracket? You square the first term, so this becomes sine squared x over 2. You multiply them together, then you multiply by 2. So it's going to be plus 2 of sine x over 2 cos x over 2. Plus you square the last term. This becomes cos squared x over 2. All over, in the denominator, what do we have now? Same thing, you square the first term, cos squared x over 2. Then you multiply them together, you multiply by 2. Positive terms, negative, your answer is negative, but it will be now 2 of sine x over 2 cos x over 2. Then you square the last term, which is a negative thing. When you square it, becomes positive, and it is now sine squared x over 2. Okay, so we have gotten to this stage now, eh? Sine squared x over 2. Now look at this. What are we going to do now? I have this cos squared x over 2. I would love to change it to a sine squared so that I'm going to just remain with the signs here. Okay, so this I can just change it. So I would say now sine squared x over 2 plus 2 sine x over 2 cos x over 2. This is going to be, this cos squared will change to be plus, cos squared is 1 minus sine squared. So we say plus 1 minus sine squared x divided by, this is going to be cos squared. With cos squared, we want to change it to 1 minus sine squared x again. It's x over 2 because all of them are x over 2. So it's 1 minus sine squared x over 2. Okay, because it's a cos squared x over 2. Remember, we did it when we did the identities, that cos squared is 1 minus sine squared. Okay? And sine squared is 1 minus cos squared. So that's what you do when you're removing them. So now it becomes minus 2 sine x over 2 cos x over 2 plus sine x over 2. What would we now have? This now becomes sine x over 2 plus 2 sine x over 2 cos x over 2. You don't have to cram this. Just try to do it and try to remember. When you get to a stage, look at it and look at what should be done. This is plus 1 minus, it's just going to be plus 1, then minus sine squared x over 2 all over 1 minus sine squared x over 2 minus 2 sine x over 2 cos x over 2 plus sine x over 2. Now what do we do now? We let them cancel. Sine x over 2 minus sine squared. Okay, because this is a sine squared, by the way. So they cancel. Then here we have negative sine squared x over 2 and another positive. So they cancel. And what we end up having at the top is going to be 2 sine x over 2 cos x over 2 plus 1 divided by, in the denominator we now have 1 minus 2 sine, is this a sine? Yes, it's a sine x over 2 cos x over 2. Now here we can put a thing. What do we know about 2 sine x over 2 cos x over 2? What do we know? Double angles. Yes, this part here, this part, okay? Remember that this would be a double angle. Where did it come from? If we say, please, what is the thingy when we do double angle formulas from sine x over 2? What would we get? It would be 2 sine, from sine x rather, it will be 2 sine, then you half this, right? That's what we're doing for double angles. It becomes x over 2, then cos x over 2. So that is what we have now. We have 2 sine x over 2 cos x over 2. So that is a sine x, okay? That is a sine x, and we say sine x plus 1 all over 1 minus, here we have again 2 sine x over 2 cos x over 2. It is a sine x, okay? But we would have changed it using the double angle formula thing. So now we'll be having sine x plus 1 all over 1 minus sine squared, which we can just rewrite to say 1 plus sine x all over 1 minus sine x. And this would be your final solution, and you would be done.